So this video is integrated 3, chapter 4, D-Day number 4. So we want to do these normal distribution problems. We're going to give our answers to 4 decimal places, and we're going to shade where we should shade for these. So let me get my normal curve drawn. Our mean they gave us was 69, and our standard deviation is 3.3 inches. Okay. So when I'm drawing this, I want it to figure out what percent is between 64 and 74 inches. So I will be shading here. This is the area that I'm going to try to find on my calculator. And this area represents a percent because the area under the whole curve is 1. And 1 as a decimal represents 100%. So I am going to do a normal CDF. And when you do go to that on your calculator, it's going to be the second one here. Our lower bound is going to be 64. Our upper bound is going to be 74. Our mean is 69, and our standard deviation is 3.3. Okay, so 64, 74, 69, 3.3. And I get 0.8703, so 87.03%. Matt is in the 97th percentile. Find his height in inches. So if we're looking for the 97th percentile, okay, our mean is 69. That means that 97% of the data is below us. So we're looking, we're looking over here. And we want this area here to be 0.97. And we want to know what height, what X there that I wrote would give us that. So this is going to be 0.97, which really means this would have been 0.03, the top 3%. So for this one, I am going to use my inverse norm, because I know my area or my percent, and I want to find the value that gave me that. So when I put that in my calculator, which is the third one here, the area is going to be 0.97. Our mean is still 69, and our standard deviation is still 3.3. So 0.97, 69, 3.3. So we get 75.216, sorry, 2066. So, whoops. So that is going to be his height in inches. That's what this X represents. What percent of the team is shorter than 66 inches? So if I have my mean of 69, I want to know what percent is shorter than 66. I am looking here. Okay. And so for this, I'm going to do a normal CDF. And my lower bound, so when I go to this, that -1 e to the 99 is scientific notation. That means times 10 to the 99. So our lower bound is -infinity, and we write it as -10 to the 99. So I actually can leave that in there. That means the same thing on this calculator. Our upper bound is going to be 66. Our mean is going to be 69, and our standard deviation is 3.3. So we have 66. We have 69, and we have 3.3. And we get 0.1817 or 18.17%. What percent of the team is taller than 72 inches? Oops. What percent of the team is taller than 72 inches? So again, 69, 72. We want to find this area greater than 72. So we're going to use our normal CDF again. This time our lower bound is going to be 72. Our upper bound is really positive infinity, but we're going to type it in as 10 raised to the 99. And then we're going to have our mean of 69 and our standard deviation of 3.3. Okay, so this is going to be 72, 10 raised to 99, 69, and 3.3. And I get 0.1817. It happened to be the same percent, but the upper 18% as opposed to lower 18%. Okay, next problem. Find the z-score for a height of 65. So z-score, we want to basically figure out how far off are we from the mean in terms of standard deviations. So I am going to take 65, which is the value we want the z-score for, subtract it, keep touching that, sorry. Subtract it from our mean, wrong direction. Okay, so we're here, sorry, highlight it. This is where I am. Okay, so we're going to take 65. We're going to subtract it from the mean to see how far off the mean we are, which we are 4 below the mean because we're going to get a -4. And every deviation is 3.3. So we're going to be a little more than 1 deviation in the negative direction. So I'm going to put this into my calculator. So I can do 2 ways. I can go parenthesis, 65 minus 69, close my parenthesis so that whole thing computes and then divide it by 3.3. And I get a -1.2121. Or I could do the alpha y equal, which is your fraction. So 65 minus 69 over 3.3. And that will give us the same thing. We just got to make sure that we do the whole 65 minus 69 and get -4 first. Okay, on the next section, we are going to be doing a relative frequency distribution with a bin width of 5 and a minimum score of 65. So we're going to start with 65 and go by 5s. So I'm going to make a table, and I'll put, these are scores of some sort, so I'll start with score, frequency, relative frequency. So I'm going to go 65 to 70, but 70 is not included there. 70 to 75, but 75 is not included there. 75 to 80, but 80 is not included there. 80 to 85, but 85 is not included there. And 85 to 90. So when I'm doing this, let's see, finding this one here, the only values that will be here look like 65 and 68. Okay, so that will be 2. From 70 to 75 will be 72. So we have 1. From 75 to 80, I'll have these. So that will be 2. From 80 to 85, that will be, whoops, I'm not going to do. From 80 to 85, that will be just the 82. So that's 1. From 85 to 90, so from 80, sorry, I didn't, hold on, 85 to 90, that is going to be these right here. That's 4. I was just going to highlight this. I didn't highlight this. That was my 80 to 85. Okay. So when I count this up, I've got 3, 6, 10, 10 total. Okay, so total is 10 here. When I'm looking at this. Okay, the total here is 10. So that means this is going to be 2 out of 10 or 0.2, 1 out of 10 or 0.1, 2 out of 10 or 0.2, 1 out of 10 or 0.1, 4 out of 10 or 0.4. And that's what I'm going to graph. Now I'm just going to go grab a graph. Okay, so for this one, let's see. On this side, this is going to be my percent. I'm going to have this be 0.1, 0.2, 0.3, 0.4. For this side, this is going to be the score. And let's see. I'm going to zoom in a bit. So I need to get from 65 to 90. Okay. So let's say that I start here, this being 65. Here, I'm going to do this a little bigger. Okay. Let's say that this is 65. And I go every 3. Let's see that this is 70, 75, 80, 85, 90, just to kind of spread it out a little bit. Okay. Okay. So then from 65 to 70, I'm going to go up to 0.2. From 70 to 75, I'm going to go up to 0.1. Here, let me do that better. From 75 to 80, I'm going to go up to 0.2. From 80 to 85, I'm going to go up to 0.1. And then from 85 to 90, I'm going to go up to 0.4. Okay, and that would be my frequency distribution. Now on the bottom here, it says, would a normal curve be a good model for this distribution? This would not, because the high point here, that 0.4, the one that has the most, is not in the middle. Okay, if I had the 0.4 in the middle with the 0.2s on either side of that and the 0.1s on either side of that, that would have been a normal curve, because that would have had a bell-shaped curve where it's high in the middle and then it's going down on either side. But this does not. So not a normal curve, because highest bar is not in the middle. Okay. Okay, so solving algebraically. So this is going to be a situation, let me make this a little bigger, where we are going to set these equal to each other. So 44 minus 14x underneath the square root is equal to x minus 6. When I have a square root, I want to make sure it's isolated. It is. Then this x minus 6 on the other side needs to not be negative. So I'm going to have to check answers here. Okay. So the first thing I'm going to do is I'm going to square both sides. And when I square both sides, this is going to be a 44 minus 14x. And this is going to be an x minus 6 squared. And when I square that, that is a perfect square trinomial. And so that is an x minus 6 times x minus 6, or x squared minus 12x plus 36. We want to get fast at doing those perfect squares. Then I'm going to get everything on one side, 0 on the other side. So I'm going to add 14x, which is going to give me a 2x. I am going to minus 44, which is going to get me a negative 8. So now I want to see what multiplies to a negative 8 and adds to a 2. So that's going to be a positive 4 and a negative 2. So I'm going to get x is equal to a negative 4 and x is equal to a positive 2. So remember, I want to make sure that it makes this not a negative. So this one here, when I go negative 4 minus 6, that's going to give me a negative 10. So that one's not going to work. This one, oops, when I put in, when I put in my 2, this is going to give me a 2 minus 6, which is a negative 4. That also won't work. So this one's going to have no solution. Neither one of them is going to work here. On number 4. So always when we factor, can we factor something out of every term? So a 36, a 21, and a 30, I can for sure take a 3 from those. And next to the third x squared x, I can take an x. That 3x is still out front. It doesn't disappear. So I'm going to have a 12x squared minus 7x minus 10. And then that, I'm going to see if I can factor that further. So I'm going to have a 12x squared and a negative 10, which is a negative 120x squared, and has to add to that negative 7x. So for this, when I'm trying to think about things that multiply to 120 and add to a negative 7, let's see. So 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and, let's see, 5 and 24, 6 and 20, 7's not going to go into that. 8, 120 divided by 8 is 15, and that's actually going to be our answer. So sometimes if you're stuck trying to think about it, kind of go through a systematic way of doing it, where I kind of go 1, 2, 3, 4, try to go that way and do all the ones that go into it. Because the first one I thought of obviously was 10 and 12, but that's not going to get a 7 for me. So I just went through a list. So it's going to be a negative 15x and an 8x. So negative 15x and 8x. And don't forget that our final answer will have a 3x in front of it. So let's see, a 12. This is going to be a 3x and a 4x plus 2 minus 5. So I'm going to get a 4x minus 5 and a 3x plus 2, along with my 3x out in front. Okay, what is the domain? So we have 2 places we have to look. Number 1, We cannot have a 0 in the denominator. So what would make that 0? 4. So x cannot be 4. So at this point, it could be anything but 4. Okay. But when we have a square root, we also have to be careful because the square root cannot have a negative underneath it. Otherwise, that makes it imaginary. So for that part here, x has to be greater than or equal to -5 because -5 would make it 0. Anything bigger than -5 would make it positive, but anything smaller than -5 would make it negative. So I'm going to have close bracket -5 to 4 with an open bracket because I cannot equal 4, union 4 to infinity. So basically it's from -5, greater than or equal to -5, but can't be 4. That's what that says. On this one, I'm going to subtract 3 first. And I get a -12. I'm going to divide by 2. And I get a 2x minus 6. So just like my square root, I have to, once my absolute value is isolated, I need to check. This cannot be negative. So when I get my answers, I need to check to see if this will become negative. So I'm going to have 2 equations, okay? One equation is going to be x minus 1 equals 2x minus 6. The other equation is going to be x minus 1 equals, and I'm going to make that in the orange circle opposite. So it's a -2x plus 6. And I'm going to solve these. So the first one, I'm going to get -1 is equal to x minus 6. If I subtract x from both sides, I'm going to add 6 to both sides, and I get 5 is equal to x. For my second one, the blue one, I'm going to add 2x to both sides. So I get 3x minus 1 equals 6. I'm going to add 1 to both sides. So I get 3x is equal to 7. I get x is equal to 7/3. So I'm going to be putting both of these into the equation to see if it makes it true or false. And I'm going to be taking each of them into here. Okay. Now, when I do the first one into here, 2 times 5 minus 6, that's going to be a 10 minus 6, which is a 4. So this one's going to be okay. When I'm doing my second one, and I go 2 times 7/3 minus 6, I get a negative 1.3 repeating. So that's not going to work. So my only answer is going to be 5. Okay, on number 7, I am basically going to solve this to get my boundary points. So one equation is going to be 3x minus 2 equals 10. The other is going to be 3x minus 2 equals a -10. So I get 3x is equal to 12. X is equal to 4 is one boundary point. 3x is equal to -8. X is equal to -8/3. So I'm going to have my number line. I'm going to have my -8/3 and my 4. I look back at the original problem. I want it to be less, strictly less than. So that means they're going to be open circles. Okay. Open circle, open circle. I need to decide if I'm a shade in between or outside. So the way I think about this is I think about this line right here being where y is 10. This is where it equals 10. I want things that are less than 10. And this is an absolute value. And an absolute value is a V-shaped graph. So as I'm going down, let me do it in the highlight. As I'm coming down here, I am on my absolute value, I am greater than 10 at 10, less than 10, still less than 10 at 10, greater than 10. So again, when I'm doing this, if I am looking outside of -8/3 and +4, you see I am above that line. So I'm greater than 10. Okay, greater than 10. Over here, I'm below that, so I'm less than 10. So where I want to shade is in between -8/3 and 4. So I'm going to be shading here. That's going to be my shading. So everything I just drew, I just use that as kind of a tool, not part of my answer. Okay. That's my answer. Oops, and I guess I had a number line down here. My answer is going to be -8/3 less than x less than 4. That is our answer. Okay, on 8. So this, when you have an x squared and a y squared, the only graph we know of right now are circles. Okay, so this is going to be a circle. So I need to begin in the form x minus h squared plus y minus k squared equals r squared, which is just basically a number. Okay. So I'm going to get my x's together. So I have x squared plus 22x. I'm going to leave myself a gap plus put my y's together, y squared minus 16y, leave myself a gap. I'm going to take that 10 to the other side, so it's a -10. Then I want to figure out what I put in both of these. So I'm going to look at my 22, which is my b. I'm going to take half of 22, which is 11, and then I square that, and I get 121. So I'm adding 121 here and 121 here. Then I'm going to look at my 16, my -16, which is in front of my y. Take half of that, which is -8. And I'm going to square -8, which is a 64. So I'm going to go plus 64 plus 64. So then I am going to have x plus 11 squared plus y minus 8 squared is equal to, and let's see, I'm taking a -10 plus a 121 plus a 64, and I get a 175. And that is our equation. Okay, trying to find the x and y intercepts. So the x and y intercepts, to find my x-intercepts, I'm going to put 0 in for y, and I get 81 x to the third minus 36x squared. I am personally going to divide everything by 9. So I get a 9 x to the third minus 4x squared. I also notice that I can factor out an x, and I'll get 9x squared minus 4. Now, 9x squared minus 4 is a difference of 2 squares, the 3x plus 2 and a 3x minus 2. So I'm going to get 3x intercepts. Oops. So I'm going to get 3x intercepts. One is x equals 0. This one is going to be x is equal to a -2/3. Sorry, I don't have my computer in the place I normally have it. -2/3. And x is going to equal a +2/3. So that's my x-intercepts. 0, -2/3, +2/3. To find my y-intercept, that's a little easier. I put 0 in for all of my x's. And when I do that, I end up with my y being 0. So my y-intercept is 0 or 0, 0. So I'm going to make a second video for the second part of this, the no calculator allowed part.